Today we're going to talk about a very different type of engine called a plasma engine. And first, let's review how our typical engines work, and then we'll talk about how the plasma engine is a radically different type of engine. Typical rocket engines combine a fuel plus an oxidizer to create a very hot gas. And that very hot gas goes through a nozzle, which converts the hot random motion into exhaust velocity, which is directed flow. The exhaust velocity is then very limited by the temperature of the combustion. And so that is one of the big issues with using chemistry to create thrust, is that we're limited by this temperature. So is there another way of generating thrust? Well, so we could generate a stream of very, very, very fast moving particles. And that's what we're going to talk about today. We're going to use physics to create a plasma thruster. So recall what a plasma is. A plasma is a mixture of ions and neutrals. And so an ion is a charged particle, so it is a plus particle, and then there are electrons which hang around also, and those are negative. And so you could take a neutral gas and you can pass a current of stream of electrons through it, and then you can generate these protons. And then doing this, if we do this just right, we can create velocities of about 30,000 meters per second or better. But there is a huge catch with this. All right, so the first thing that we do is we take a gas and then we put a stream of electrons through it, which is a current, and that ionizes our gas. Then we apply an electric field to our gas, all right? And the way that we do that is we have a mesh and we apply something like a battery to it. One side of the mesh is hooked to the negative side of the battery. One side of the mesh is hooked to the positive side of the battery, and that creates an electric field. And that electric field then causes the ions to move in one direction and the electrons to move in the opposite direction. All the ions, because they're positively charged, they're attracted to the negative plate that we have created. And so they move towards that negative plate very quickly. And the electrons move towards the positive plate very quickly. Then what we do is we actually, instead of making just a solid plate, we make a mesh, like a screen. And that mesh actually is just a bunch of wires going back and forth. And the ions can sort of slip through the openings. So the mesh is negative charge, and the ions move towards it, and as they get closer and closer and closer, they go faster and faster and faster, and then they pass right through that mesh. They're accelerated to very fast speeds. Those ions are moving very, very, very fast, and they have some mass because the ions are actually like atoms, and so they have some mass. They're moving very fast. And so that is the definition of thrust. Mass with some velocity is thrust. You get speeds of 30,000 meters per second to 50,000 meters per second. That is 10 times larger than any exhaust velocity that we've really talked about in the past. And so this is a revolutionary new type of technology. But there's a catch to this. The problem is that it takes a huge amount of electricity to ionize the gas. So that means that the mass flow rate is incredibly small. Very, very, very small. So for example, it could take up to 100,000 watts of power to produce 1/2 gram of mass per second. That is 0.0005 kilograms of mass. So even with 30,000 meters per second, exhaust velocity, that's not very much thrust. If the exhaust velocity is 50,000 meters per second, and you take this 0.0005 kilograms, that produces 25 newtons of thrust. that's not a number that many people understand. A Newton is roughly like a quarter pounder. And so that is 25 quarter pounders, right? Go to McDonald's, order 25 quarter pounders. You can lift them up. It's not that hard. That is how much thrust you get at 100,000 watts of power. All right. That is the big problem with plasma thrusters. And 100,000 watts would take roughly 300 square meters of solar panels. That is a gigantic amount of solar power that would be needed to run this engine to get a thrust of 25 newtons. So the question is, why do we do this? Well, they're extremely useful if you have enough time. So they are extremely low thrust. Most are less than actually 1 newton, but you can operate them for months because the mass flow rate is so incredibly low that you're not using like a gigantic rocket full of mass. You're using just like a little brick. That, remember how many zeros there were in that kilograms? Like it was 0.0005, right? And so that's such a small amount of mass that you're using per second that you don't need very much mass of fuel to move you for months and months. Once you put the satellite in space, you can use a plasma thruster to move that around. All right, and that's what we do. So there was this thing called Deep Space One, which was one of the first ion thrusters in space, and I call them ion thrusters or plasma thrusters. They're the same thing because ions and plasmas are pretty much the same thing. It used a new star ion engine, and it was part of a technology demonstration mission for NASA. It flew by an asteroid, which was 9969 Braille, and several missions after Deep Space One have used ion thrusters. So this mission, one of my favorite missions that's ever been launched, is called GOCHI, or GOES, as some people call it. And it used an ion thruster to actually stay orbiting at 250 kilometers altitude for almost 4 years. Why is that amazing? Who cares? 250 kilometers altitude is an impossible altitude to stay at because the drag is so large there that if you did not thrust all of the time, you would deorbit within weeks. All right. So if you took the International Space Station and you lowered it down to 250 kilometers, it would deorbit very quickly. All right. And so GOCHI actually used this ion thruster to counteract that drag force, and it stayed at 250 kilometers altitude, almost exactly 250 kilometers altitude, for 4 years until it ran out of fuel in the plasma thruster, and then it decayed. There are variations of a plasma or ion thruster, and one is called a magnetohydrodynamic thruster. And basically what that does is it uses magnets to direct and accelerate the plasma. It uses the same type of thing, ions and electrons, and it accelerates them in the same direction. And that is actually really technologically important. We won't get into really why it's technologically important, but you use basically magnets with the electric fields, and that causes the ions and electrons to both accelerate in the same direction. Recall that with just an electric field, the electrons go one way, the ions go the other way. If you add magnetic fields to that, you can get the ions and electrons to move in the same direction, which is great. So then there's the pulse plasma thruster, which basically, like, you take a capacitor, which is like a very large battery, and then you charge that. And then you discharge that capacitor into a solid material, which you ablate, which is vaporizing that solid material, and you vaporize it into a plasma. And then you use magnetic and electric fields to accelerate the plasma out of the back again. And this is slightly different because instead of using a gas, you're now using a solid material. All right. And then you basically charge this capacitor, you discharge it, you charge it, you discharge it, charge it, discharge. And that's why it's called a pulsed plasma thruster. So in summary, a plasma or an ion thruster creates ions and accelerates them out the back of the engine. There are several variations that use magnetic fields or technologies to improve the basic design of this. But still, the basic design is you create ions, electrons, you accelerate them out the back, and you can get exhaust velocities that are 30,000 to 50,000 meters per second, which is just unbelievably great. But the rub is that the mass flux is extremely low. On many of them, you have less than 1 gram per second being accelerated. And so that gives you very, 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 very low thrust capacity. But you can run for months and months and months and months because you're using such a low amount of mass per second. So you can't use this to get things off the ground at all. There's no possibility that this will ever be used to get things off the ground. But once you are in space, then you can move satellites around the solar system. And we have done that with several different missions using these plasma thrusters.